Today I will introduce Divergence Alert (DRAG), a system that detects when market sentiment and stock prices move apart. So the problem and hypothesis: market move on facts and feelings. When sentiment from news, filings, social media diverges from price return, the gap can be a signal. Price here, all those news filings, social media is ST, which is sentiment, and the price, which is stock price. ST minus BT is greater than theta. So theta is the main our goal. Our goal is to detect those events early and explain that why sentiment and price is apart. In high level architecture, the system is 8-node pipeline orchestrated by LangGraph. It ingests market data and text, embeds document with FinBERT, indexes them in FAISS, Facebook AI similarity search, re-ranks candidates with CrossEncoder, verifies temporal and ticker consistency. By temporal meaning time. Everything is because any financial news today is different than few minutes later or few seconds later. So that's the temporal thing here. So and then does z-score analysis and then finally generates an explanation using two collaborating agents. A CrossEncoder re-ranks the top candidates for precision. A deterministic verifier checks timestamps. The generator runs two agents in parallel. The analyst extracts sentiment and narrative. The risk agent assesses regulatory and volatility signals. Their output are synthesized into a concise evidence-backed explanation with provenance IDs. So all data that is retrieved is all has some timestamp associated with it, and just going to cover demo first. So now I'm using a Streamlit Run app. I just to hit enter. So this is my interface on 8502 TRAC configuration. Demo is there in live. If I click on demo, it just goes to it refers to the all fallback files. And if I hit on live, it will hit on my real models. And to save cost, I had to come up with demo version. So let's say I just go here and click on live API for the time being, and just click, let's say, for Apple stock. And right now date range is not set. I'm just going to click on let's say 9 and the 10th and date. I'm enabling here multi-agent. This is configurable. I can just remove and enable LLM cache. And the moment I just click here, execute pipeline. So you see here, pipeline is getting executed. If I can show you the, I'll show you maybe probably if I'll get time, I'll show you is how it is happening. But meanwhile it is running, I can show you different tabs quickly. So this is observability console, which will show each and every second what is happening. And these are the results. And this is pipeline architecture. Pipeline is completed. And I can just go back and show you quickly to save some time. So you see here, planner is done, ingester is done, everything is done. How many documents were ingested is 1, divergence event is 1, confidence is 78%. Right? If I just show you here a planner, you can see that how many documents it has retrieved: 5 documents, 2 sources, and 1 tool call. It can change depending on how efficient. Sources, these are the news, which is news data API, and this is Yahoo Finance. If I go here and just show you quickly ingester, this is how the temporal thing comes into picture, that each event you can find the date and reach out to that document. These are the sample documents, market data. Retriever, this has retrieved 4 documents. Reranker, what it does, it has actually, out of those 5 documents, it has got these 3 documents and the scores that it then. Verifier evidence validation, it has verified all 3, 100% confidence. Then detector, it one event, which is sentiment price divergence. Here you see description, positive sentiment, and then quickly generator, which is multi-agent report. This is the most important thing. Here it is giving you all the entire report. It has detected one divergence event requiring attention. Primary event is primary event is this, and then this has given market sentiment shows mixed or neutral signal. This creates divergence with sentiment price divergence, suggesting a disconnect between market perception and the actual price action. So here this is the main kind of narrative it is giving. And then risk assessment, regulatory risk level is low. Auditor meaning all the logs, all alerts, everything is here. Now I can quickly show you the pipeline flow diagram. Planner, which is React agent, ingester, retriever, things I'm just going to show you in code. Yeah, so coming back to this code piece, so if you see here, these are the agents I'm using. So this is planner agent is the main agent, which was the top agent, which initiates everything. So if I just show you briefly, this is the one which is React planner agent, which is part of LangGraph. And then Analyst agent, its responsibility is to analyze sentiment trends from news and social media. See, it is using LangChain planner. And then risk agent is basically for regulatory stuff. Then ingester, so if you see here, this is exec parser, which actually, this is PDF parser, because unstructured was very heavy for my laptop. News fetcher, which is fetching news from, which is evidence based ID, EVID. So news API, they already provide this data. Market fetcher, fetching market data. And quickly, this is ingester. These are the agents. Agents are ultimately calling all those processes. These are the utilities. This is RAG pipeline. So RAG pipeline is basically, intelligent stuff, temporal decay, CrossEncoder, everything is happening here. Self can ask the, for example, I give Apple or Tesla, I can give Tesla, and it will return top 10, top 5, top 3, depending on how agent is behaving and depending on what is I'm setting up. This will call embedded reranker, and reranker will be CrossEncoder, and then temporal decay. And then this is ndjson files, which each time I'm running code, it will return something similar, which is JSON, but very much streaming. You can stream this data. This is LangGraph, architecture of LangGraph, which is used. The planner is there, then ingester, retriever or reranker, verifier, detector. This is a run graph, and then here it is state, which is retrieved by all those agents. Thank you so much.